In this video, I'm going to share a real example of polymorphism in program design. Polymorphism is a part of object-oriented programming. It means that you have one kind of object, and it can take many forms. Rather than just giving you a simple abstract example, I wanted to show you how polymorphism works in a real program. So this is my program. It allows you to build different buildings on a 3D landscape, which is definitely not inspired by Minecraft at all. Anyways, you can build different things, and each building can be placed in different ways. The rules for placing a building, like how many squares it takes, what's its maximum size, come from an object that I call a selector. Each building or action that you can take is listed here. Each entry has a property called selector. So there's a flexible rectangle selector, a connecting selector, a fixed rectangle selector, and so on. So when I want to make a building in the game, its selector can just be dropped into the program. The way this works is through the interface, which is the heart of polymorphism. An interface specifies what you want your object to be able to do. Now, this is TypeScript with React, but interfaces show up in many other programming languages. In this interface, which is called selector, you can see different method declarations, like the declaration for handle mouse over target. This declaration specifies that this method takes one parameter, which is an object of type selectable, and it returns nothing. It's void. There is no method body, no implementation on the interface. Instead, when we create an object that is a selector, we will provide the implementation. In this way, we can have our different objects provide different implementations. So let's create a selector. I'm going to create a cat selector, and I will specify that this cat selector implements the selector interface. Because I specified that, the compiler, or transpiler in this case, checks to make sure that I have implemented all of the methods of the interface. Now I haven't, so the red line indicates an error. Now, every object that uses this interface has to have all of those methods. Here I'll create an implementation. I'll create the handle mouse over target method. It's just going to print cats to the console. All right, so after that, I'm still getting an error because I'm missing the rest of the methods. Let me add those in. Finally, I just need to export this selector so that it can be used elsewhere in the program. Now I can change my selector for the tent, for example. And when I start the program, and I hover the mouse over different squares, each time the mouse goes over a different cell, it will print my message about cats. So that's great. I got cats. But notice that we never actually had to call the method ourselves. The new selector just gets dropped into the program where a selector is needed, and it works. That's one of the benefits of using this kind of approach. So the selectors that I created for this program include one that allows single buildings to be placed or even connected together, one that allows single buildings covering multiple squares to be placed and stacked, and one that allows multiple buildings to be built at the same time. And they all work by creating different implementations of the methods in the selector interface. So we just looked at the selectors, which are polymorphic objects. To complete the example, I also want to show you where these selectors are actually dropped into the program. For that, we'll open up the mouse event handler for this program. This is the code that actually uses the selectors. Scrolling down a bit, we get to the setSelector method. When this method is passed in a new selector, it adds that selector as a private member to itself. The pound sign in JavaScript just means that this is a private not a public field. So let's add a console log statement here to print out setting selector to, and then we'll also add in the selector itself. Then we'll try the program out again. Now, when we change buildings, we can see the new selector getting dropped into the mouse event handler class. Scrolling further down, we have a onMouseMove method. Now there's a lot of boilerplate code here for getting the 3D object under the mouse cursor. We have to get the intersected objects, find a valid target from those intersections, make sure it's not null, and then consider whether we're in selection mode or not. Finally, we can actually implement the logic we want. So here I could write console log. This is a call from the mouse event handler. And now, when we move our mouse to a new cell, the message shows up, just like it did for the cats. Okay, so instead of just writing a console log statement, it could implement all of our selector logic directly in this spot, like mouse over target dot hover. The problem is that we have a lot of boilerplate code here that never changes, while the logic we use for each building changes quite a bit. So one part of the code never changes, while another part of the code changes all the time. It would not be a good idea to mix these together. So instead of writing that logic here in the mouse event handler, I'm going to just call a method on the selector object. And I'm going to let the selector take care of all that logic with its own implementation of the handle mouse over target method. And here is the awesome part. Although each selector is a different object, they all implement the selector interface. And so they are all guaranteed to have these selector interface methods. Like, there will never be a point where the mouse event handler tries to call this method and the method doesn't exist. So with TypeScript and other strongly typed languages, the IDE can even pick up on this and show you the methods that are available to this object. So to wrap it up, the selector system that this program uses is an example of polymorphism. Here, different objects, the selectors, they implement a common interface, which is the selector interface, but their implementations are different. And that allows you to drop these objects into the program to get different effects. This also allows you to decouple parts of the program that rarely change with those that change frequently. So if this was helpful in any way, give me a like or a comment, and I'll see you in the next video.